right, welcome back. We're now looking at 06A-60. So we have a regular trapezoid. It gives us the regular trapezoid area to be 372, along with an angle. So since it's a regular trapezoid, we know that the angle over here must also equal 66.7. Let me write that down. 66.7 degrees. And we're given that M is the midpoint. So this right here is the midpoint of the entire triangle. AM, so that distance right there, is also equal to BM. So we know that's an isosceles triangle. So if this is 66.7 degrees, that must also be 66.7 degrees, right? They are isosceles. Uh, since they're the opposite sides are the exact same, using law of cosines, just law of cosine. It's getting late. Uh, we must know that that angle must also be 66.7. We use that to our advantage by first connecting this trapezoid in half. So I'm by chopping it in half. So that's the first step I'm gonna do. Chopping it in half makes a right triangle, a right angle, sorry, uh, with the plane. And now all we really have to worry about then is just these two triangles then, right? So if we find the area of these two triangles and then double it, we can set that equal to the entire trapezoid area. So looking at the first triangle, we don't know any angles yet, right? Because sure, we know that the angle at the top must be 90. Let me redraw it one more time. The angle at the top must be 90. But we don't know anything about the other two angles. However, we can solve for this one. As I said, since this one must be 66.7, we can solve for what that last one must be because of the property of all quadrilaterals. I'm slurring my speech. Uh, all of the angles in a four-sided shape must add up to 360. So if we do 360 minus 66.7 times 2, because there's two of them, divide that by 2, we're left with what the other two angles must be. You subtract that from 66.7, and you have what this angle must be. So we know now that this angle right here, if I can draw, this angle right there is 46.6 degrees. I'm going to make that a little bit more bold. 46.6 degrees, right? Uh, and since we have what that angle is, we can now put everything else into ratios. I'm going to call AM is equal to BM. So really, we're just having to solve for what this side is. I'm going to call that X then. So that's X. This must also be X, as we already said. And to find the area of this, we'd have to have the bases, right? Or the legs of the right triangle. So we could just call this side to be X sine of 46.6. Let me change my hand a little bit. Sine 46.6 degrees. And then this side must be X cosine 46.6 degrees. Okay? And then looking at the bottom triangle, I'm going to just split it in half. So let's go ahead and draw a line, just splitting it in half. Again, it might not be perfect for my diagram, but hypothetically, those are two right triangles, exactly the same. Same angle, same right angle, and then same side. So you know they must be equal. Now, this side, we could put, again, to be, I would say, the cosine. And to get the entire base, I guess I could write 2 times it, but I'll just write, for this single side right here, we'll change colors. For this single side right here, yeah, we'll do blue. We're going to say that this right here, this side is equal to x, the hypotenuse, times cosine of 66.7 degrees. And then for the height, it's going to be x times the sine. 66.7 degrees. And again, that is the height right there. Okay. You get the point. X sine of 66.7. All right, so now all we have to do is just plug that into our calculator. So the first triangle, this red one, is going to be those two sides multiplied together and then divided by 2. So it becomes x squared sine of 46.6 cosine of 46.6 divided by 2. And then these two sides multiplied together. Because again, it's the base times height divided by 2. Well, that's half the base. So we could just write it as half the base times the height. So then that would become x squared. And then cosine of 66.7. And then lastly, sine of 66.7. And we set that equal to, I believe it was 372. Sorry, I wrote over it. 372. And again, we're going to have it because we're only looking at half the half the trapezoid. And we get x to be 17.4, which is our correct answer. So if you missed it, don't feel bad. It is a bit tricky. But if you had a faster way of solving it, please let me know. I've always tried to encouraging that in my videos. If you might have a faster than I do, or maybe a better way, just in all honesty. I'm open to ideas. So thank you for watching. I'll see you tomorrow, and we'll go over 06B-60. So you all have a blessed night, and take care.